Hello, I'm Trent Rosenthal, and in this video I will be showing what the development process is like for the Quantum Circuit Simulator and for the Qubi Programming Language. So currently I have open Cursor, which is an integrated development environment for programming, and the thing about Cursor that sets it apart from maybe Visual Studio Code or some other coding environment is that it's heavily based on AI. And as you can see, we have our coding agent tab over here, which we can ask questions and it will directly edit the code files. And a couple of years ago, if I wanted to code something with AI, I would usually ask a question to ChatGPT and it would provide me with a code file, and I would copy and paste that into a directory such as this one. And then I would run that, and if I got an error, I would copy and paste that code back into ChatGPT and ask it to solve that error, etc. But the reason why that methodology is so flawed is because you can't really, have very large files like on this one. I asked the coding agent to count how many lines of code are in this project, and it told me about 110,000. Now, trying to copy in 110,000 lines of code into ChatGPT would be impossible. They would not take that many. And having it directly edit those files is also impossible, because what it does is, maybe you paste in the contents of one of your code files and it will send you an updated version, but you actually have to go and replace that yourself. So if you're working with maybe hundreds of different files like you're seeing here, we have 165 files with code in them. That would just be impossible to, paste into ChatGPT or one of those web-based LLMs. So instead we use Cursor, we ask it questions, and it will directly edit all of the code files. It's a pretty neat system that we have going on here, and extremely cheap as well. This is $20 a month for Cursor Pro, which gives you a whole lot of requests. I mean, I initially was using it for $0 a month, because if you have a EDU educational email address, it will actually give you Cursor Pro for free for an entire year. And that lasted me about 3 weeks out of the month before I eventually ran out of tokens for the month. And so by paying that $20 subscription, my reasoning behind that is that if that also lasts me 3 weeks and it resets every month, then that should be 6 weeks of usage every month, which means I should basically never run out. I mean, I could even use 1.5 times the amount that I'm using right now, and that would be on the border of running out. But I digress. Getting into sort of the development process, right now I have some ideas that I'm working on to what I can add to the Quantum Circuit Simulator. So the first thing that I'm going to do is I'm going to open up a live server, so every time the code updates, I should be able to see that updated code. And to do that, I use this following command. Now, you may have to download different things if you don't have all of this configured already. I believe this is in the Node Package Manager that you have to download, but the command that I use is npx space http-server and then space .c.1. I believe this .c.1 makes it so it doesn't really keep like any cache. So if I'm updating code files very quickly, it won't try to cache one of the old ones and try to use that. And if I'm updating it, then I wouldn't be expected to continue using the older file. That's what I believe the -c-1 does, but anyways, I'm going to hit enter, and it should take a second to load some stuff in here, but eventually it loads everything correctly. And if I go to this address, this 127.0.1, 127.0.0.1, and the port number is 8080. If I go to this, then I will now have the Qubibyte website loaded in, because that's the file directory. It's Qubibyte website. And if I want to go to the simulator, which is what I will be editing, I can type a /simulator in this link and hit enter, and it should load up the simulator. So now I have the simulator loaded up, and as you can see, it's formatted a little bit strange because I have a bit of a smaller tab right now. I'll expand that out later. But I do have written down, I have a list of different changes that I would like to make, and it's not completed yet, so I'll be typing that up in the video. I'll speed that part up. But basically, I'm telling it I want it to add conditional blocks to the Qubi syntax. So I wanted to add stuff like the if statements, and I try to, reason with it a little bit. I don't want it to do too much at once, and then maybe it does it all wrong, and not only am I burning a lot of tokens, but I'm also burning a lot of time. So instead of doing the whole while statement and maybe a switch case if I want to add that, I'm just telling it to create an if block in the syntax, and I'm telling it in a few different formats, so there's really no ambiguity on what it should add. For example, I'm telling it we can do something like if x is greater than 5, and it will know based on the context of our conversation that x can be a variable, but actually to even maybe clear that up a little bit more, and I hadn't considered this before, I'm going to actually type if name of variable, just to, clean up any ambiguity that could exist and make sure that it's doing everything as expected. I put if name of variable is greater than 5, then apply the Hadamard gate to qubit 0. I'm also saying you can also do if parentheses name of variable greater than 5. It probably already assumed that, but again, we want it to be understanding us as clearly as possible. And I usually put after, so many statements like I just did in my sentence while I was explaining it. But I usually put after a lot of my sentences on here. I don't know if that really adds any benefit, but I believe if it sees something like this, that should incentivize it to look at sort of the context of our conversation or look through all the code files, and instead of making maybe a random guess on what I'm meaning by this statement, it will try as hard as possible to make sure that it does actually know what I'm talking about. Then I also included an example, so I said, for instance, or if we did something like if and then a parametric sweep or a sweeper variable 1.10 is greater than 5, and this is so it knows that this also works with parametric sweeps. In this case, if we were to run 10 different sweeps, 5 of them would pass the if block. 5 of them would be 1, 2, 3, 4, and 5, which are not greater than 5. So 5 of them would fail, 5 of them would pass. So just even typing something like this, it now knows there's going to be sort of multiple different realities in this, right? Some of them will pass, some of them will not pass. And that should give it a little bit more context on what exactly I'm expecting and what it should be implementing when it actually does begin implementing these features. I'm also saying another thing I wanted to add is if you want to do it with the value of the qubits, you can do something like if C0 equals 1, or just if C0 with parentheses, of course, or if C0 without parentheses, or if C0 equals 1. And the reason why I didn't even put the equals 1 here is because in a lot of programming languages, if you just type it like this or like this, that will be assumed that, especially in cases where it can only be a binary 0 or 1, like these measured values, if you just include it like this, you're kind of doing like a logical statement where you're just saying if this exists or if this exists and it's in the one state. So that's why I included it like that. I gave it a bunch of different examples so it knows to do that itself. I'm saying all these would be valid, but it would also lead up to another big point because when you measure a qubit, it collapses, right? We can't just measure a qubit without it collapsing into the state of either a 0 or a 1. And, of course, the frequency of either one is going to be dependent on the probability of it collapsing into either state, which was determined by the circuit up to that measurement point. So I'm saying using something like measure should measure the qubit and store its value in the matching index, like Q0 goes to C0, etc. Again, really no point for me to say anything after just this, right? If I could say, Q1 equals C1, Q2 equals C2, but just saying Q0 goes to C0, etc. would emphasize that point enough, hopefully, so that it understands where I'm going with this. And that could still lead to a lot of ambiguity, and this is where you sort of have to think like a programmer, and if you're just vibe coding and you maybe don't have too big of a background in programming, it's maybe not going to be as effective. But you do have to consider a lot of edge cases. So I'm saying And I guess if you try to measure C7 and it doesn't exist because there's not a Q7, or maybe there is a Q7, but you never called measure for it, then those should be errors. And again, I'm saying but if I didn't include this, it wouldn't really know what I'm expecting in terms of what if a situation like one of these occurs. And actually, this isn't even usually how I type this. I would maybe also type something like, and consider all edge cases with potential errors and handle those accordingly. And the reason I'm typing that is because I actually cannot think of any more edge cases, but probably more of those exist that it can think of, and I do want to be clear with it that it should be handling those accordingly, however it deems fit. By just typing this, that's putting it into the conversation so it knows that I believe it could be more nuanced and that it should do a little bit of checking to see if there are edge cases like that and to handle those accordingly. So after that, I continue going more in depth into what I want. I'm saying, obviously, this means there's going to be multiple realities because I'm expecting the qubits to collapse when measured. So there will be, and maybe I should be more clear on this, I'll say one reality where a qubit falls into a 0 state and one where it falls into a 1 state, although sometimes more likely one than other, because, if you apply like an RX gate and it's got a very small angle, that will maybe be a 90% chance of a 0 and a 10% of a 1, so that is true. Sometimes one is more likely to happen than the other, and sometimes one doesn't even happen at all, like if a qubit, and I'm just fixing these typos, I think it probably could handle those pretty well, but just for myself, I'm fixing those up, and I'm saying, like if a qubit only has an X gate applied to it, so it's 100% in the 1 state, and then measured, it wouldn't even have a reality of being measured as a 0. So I want you to add like a little reality tab that is a little tab at the bottom, and this is actually where I decided I should make this a video, so I didn't finish this, but I will. And my exact vision for this is that if we go to the measure gates, or just the measure functionality, what I'm envisioning is there's a little tab at the bottom here that's probably going to be green as well, and it should have one of these arrows pointing out of it. There's a little tab here, it has an arrow and it points to the right, and when you click that arrow, it should have a pop-up that says something like all of the possible realities that can happen, like maybe this can be a 1 and this can be a 0, or this can be a 1 and this can be a 1, and no other realities. Then I would have envisioned it to say like almost something like this, where it says 1 0, 50% chance, 1 1, 50% chance. And it's maybe something like a scrolling tab, and you could scroll down and choose what reality you want. And by default, it's not in any of the realities, and it's just telling you the overall probability of all of the states based on everything before it. But if you were to click on one of the realities, you could see the outcome of the circuit, which would again be something like this, just based on if this does evaluate to a 1 and if this does evaluate to a 0 and whatnot. So let's go ahead and maybe emphasize that to this. So now I have a lot of it typed out, and I'm just saying like that I wanted to add a little reality tab. That's a little tab at the bottom of the placed measure gates, and it has an arrow pointing to the right, which I mentioned before. And when you click or tap or whatever, and the reason why I'm saying click or tap or whatever is because I like that mobile compatibility. So by mentioning tapping, I'm saying that I want it to work well on mobile as well. And I include or whatever just in case, again, I'm forgetting something. It can think about that for a little bit and see, exactly what I'm forgetting. But I say on the arrow, it pops out a little section that should go over the other gates, and I should probably type go above / on top of. And that's just because sometimes when it's adding stuff like this, it's not really thinking about that, and it's going to display ugly sometimes. So by mentioning that, it should know that I do want this to sort of overlay on top of anything that could possibly be to the right of it. And then I put, and says all the realities and their probabilities of happening, and it actually lets you choose which reality you want selected if you want to see how the circuit behaves based on that reality being chosen. For instance, if you had a Hadamard gate on Q0 and an X gate on Q1 and measured both, you should see a 50% chance of 1, 0 and a 50% chance of 1, 1. And I'm reiterating, again, make sure that the qubits are collapsed regardless because they are being measured here. Just the measured ones and those affected / entangled / whatever by the measured qubits as well. And this was really important to mention because I actually didn't really make any mention on what you should be doing if, for instance, we have Q0 being measured and Q1 not being measured, and Q1 is dependent on the value of Q0. Then that should naturally entail that when Q0 is measured, Q1 is going to be affected as well. So, I myself am not really too knowledgeable on how exactly the behavior is going to work out there. I'm just telling it to figure it out, and I guess if I notice any errors along the way, I'm going to further inquire about that and try to get those resolved if those come up. But now I'm saying, and by default, it's not down any certain path or not down any certain reality, and is simply giving the probabilities of the circuit as normal based on the perspective that any of those could happen, and any of those realities have different probabilities. I'll put, and all of those realities have different probabilities, and factoring all of that in. So maybe one of the realities is that Q1 and Q0 are a 1 and a 0, and the other is that they are a 1 and a 1, and maybe based on that, they have different probabilities for how the rest of the circuit behaves. Then just factoring all of that in, we should by default see in this probabilities tab, we should by default see the overall probability of all of the states being measured, considering all of the different realities that it can branch down. So that's a pretty good description. I'll maybe say, and don't forget about the classical registers like C0, etc. as well. I actually do want to mention to the coding agent as well how to handle different things, like if we're measuring here and then maybe measuring twice in one circuit. So I'm going to go ahead and make those changes next. So now I'm yapping a little bit more to the coding agent just to make sure there's absolutely no confusion, although I'm still expecting some confusion and to fix some errors when it finally produces this, when I finally send this to it. But I do want to optimize the process as much as possible. So I said, first off, don't forget about the classical registers like C0, etc., just so it remembers that those exist. And then I'm saying, if there's cases where maybe there's multiple times the across the circuit that measure is used, I would expect the C0, etc. registers to get overridden whenever a write or a measure happens, with the assumption that the user will save the values that they need to their own defined variables. And I should maybe clear it up even more and say save the values from those registers that they need to their own defined variables if they need any longer retention. And make sure all that reality stuff works well. Like if you choose one reality path to bring a measure down, then maybe the next measure gates can only have states like, a few different states with different probabilities. But if you were to choose a different path on the first measure, maybe the second measure may only have a few different states with other probabilities. So be sure to consider all things like that when designing this and making all the options the user can do and whatnot. And I would assume the options for the measurement object may be something like this, where we have the path that it can go down and the probability of that path happening, and then any possible children that can arise from that, and then other paths as well, where like it'll store, I've said pretty much exactly that too, it'll store each path and the combination of that path and its likelihood. And the third thing would be the next paths it could take if multiple measures, question mark, I don't know. That's just my vision, but do whatever works best. So I'm not restricting it to doing this, but I'm saying this is how I am envisioning that it can do this. Then I'm saying also make sure that even for instance, Q0 and Q1 are the ones requested to be measured, but maybe there's also a Q2 that's dependent on Q1 that should be factored in when creating the path, because now there might be a 001 and a 101 and a 011 and a 111, but in this case you wouldn't make any saves to C2 unless the user requested to measure Q2, but you would still account for Q2 when making all the possible realities. And that's just because maybe you're measuring 01, that would maybe also have an effect on Q2, which could be a 0 or 1, based on its dependency to Q0 and or Q1. So now I'm saying also for if instance, there's Q0 through Q3, and we want to measure Q0 and Q1, and Q3 is dependent on one of those first two, and Q2 has no dependencies on any of those, then the paths may look something like 0x11, 1x11, etc., with the x being a don't care, which is something a little bit common sometimes in programming. They'll have a don't care, which means that it can really be whatever, and it doesn't really matter. And this part right down here was from me typing it up before, and then I changed something a little bit, so I'm going to delete that. And now I think I've probably maybe covered enough. I mean, this is a whole lot that I've typed here. And this wasn't even the main point. The main point was to, first start off with the conditional blocks, but I went down this whole rabbit hole, but this was all stuff that I wanted, so that's all right. So I'm going to say make sure the if block also kind of works in a similar way, but that's going to be dependent on what its condition is. So maybe it'll only run its block if C0 and C1. And when I typed this, I realized I do want the syntax to be so we could type the double ampersand, or we could say and, or for the or statement, we could type the double bar, or we could say or we could type the double caret, or we could say XOR, and whatever other logical stuff there could be. But then I get back to my main point, and I'm saying, or maybe it's the case where we do the parametric sweep is greater than 5 scenario. Either way, by similar way, I'm meaning that in general, by default, it'll show the end probability of the circuit to be the overall probabilities, but if going down one path, like with the parametric sweep, it's the path where it's just a 3 greater than 5, then that if block won't specifically run, but if it's a 7 greater than 5 path, it would run. I'm going to move that question mark to be right here, and then I'm going to make sure that it can add the else and the else if. So I'm going to say, make sure you can do else and else if, and else if, and else if is interchangeable as well with else if. So you could do like if else. Oops, I should type the condition here. If whatever, else whatever, else if. Oh, I should type this in the correct order. There wouldn't be anything for the else, but there would be something here, so else if whatever. I'll go ahead and copy this and show it that it does work if you just have no space here as well and just do an else if. And then finally, I'm going to type, I think that's pretty much it. Make sure to deeply consider all edge cases and potential errors, and be absolutely sure you don't break anything or do anything wrong, which obviously it can't be 100% sure, but by typing that, I'm emphasizing that I do want it to be very careful with what it's doing, because it could potentially break other things. And so I'm going to say, I usually throw this down at the end. I put make no errors, make no mistakes. Maybe, I'll type make sure this is done perfectly. This is crucial. So now I think I have pretty much everything I need. I wouldn't expect it to work 100% fine on the first attempt, but hopefully it does something a little bit well. And I'm actually going to make sure, one last thing that I emphasize, that I do want it to have the if block show up on the circuit and appear as I would expect. So I'm going to type and make sure the if block is under the built-in gates on the sidebar, and we can drag it in and edit it and whatnot, and it works as expected, as regular, and have it add an else block and an else if block to that same region in the sidebar if the circuit already has an if block placed. I guess just do whatever is great and make sure there's no errors in it. So now I'm pretty happy with all that I've typed. It's obviously a lot of work, even if you may think that coding with AI is just having the computer do all the work. I mean, I've just typed this whole 6,000 character paragraph here, or maybe a little bit more than a paragraph. So I'm pretty happy with that. I'm going to paste that into the agent, and I'm going to, hopefully, I will get back once it finally finishes. It's 9:32 p.m. right now. We're going to see, I mean, it's on auto mode, so we're going to see how long this takes. But we're going to go ahead and submit this, and I will cut this back once it completes the request. So it took about 50 minutes, but it finally completed. It did a whole lot of stuff. It asked me a few questions on how I wanted different things implemented, in terms of, should it make the if stuff first, or should it make the measurement stuff, or should I do them at both the same time? But it went ahead and completed all of that. I haven't actually looked at it yet, so this will be my initial reaction to the new code being generated. And noticeably, there's nothing new yet. You'll see there is actually the if, the elif, the else, and I guess it went ahead and made its own end block for the if, which I did forget to specify if it should use the end or the end if. I might ask it to change that, but let's go ahead and I guess see how this looks. So maybe I'll just drag in the if block to begin with, and it is asking us to make a condition here. I'll go ahead and maybe I won't do an X because an X gate exists, but I'll do like var name greater than 5. And yeah, var name's not defined anywhere yet. Let's go ahead and see if this end if works. It does. And it puts the closing bracket there as expected. I'll go ahead and I guess define var name to be equal to 1.10. So now that's going to be a sweeper variable. And we'll go ahead and do something like Hadamard on the 0th qubit. So maybe if we sweep through this, it's not greater than 5, still not greater than 5, and the next time I press it, it looks like the Hadamard gate is successfully working. So we at least have some functionality in this if statement. Let's go ahead and see what happens if we put an else if in here. And I forgot the condition. I'll say else if var name greater than 3. And maybe we'll do an Rx 0 and we'll do 30 degrees. And so that's interesting that it didn't put a separate if statement, or it didn't put a separate end statement for the if and the else if, even though there's a closing bracket here. And I don't know if I like it that way or if I'll change it. It doesn't look too bad. Maybe it would look a little bit worse if it had the end block and then another else or else if. But let's go and see how this works. So first 3 should be fine. This one, yep, it should be 30 degrees tilted. And if we keep going, now it reaches greater than 5, so it's going to do that Hadamard instead of the Rx. And we keep going, and looks to be working fine. I would say maybe something I'll ask it to do is maybe like gray this out or make it a little more obvious when we're on a certain combination, if this part isn't being run or this part isn't being run or none of it's being run, to make it look visually a little more clear what exactly is happening. But now I guess we should try the second part of this, which was all of the measurements. So if we go ahead and remove this, the simplest way that I thought of to do this is that if we go ahead and apply a RX gate, we'll do RX 0, 0.5, then we'll measure 0, and then we will do an RX 0, 0.5 again. First off, noticing there's no little tab, which I requested there should be a little tab here with an arrow that pops out, and it looks like that did not happen at all. And it also looks like the measurement isn't exactly working for the C0 thing as well, and we can probably test that by doing something like this maybe. Yeah, it's not even recognized. I'm not even sure if it completed that part, or if it only, I think it maybe only did the first phase. And yeah, that would be true. That is the way that I requested it, although I assumed that it would do all of the phases in just one request, but it seems it only did phase 1 in one request, and now it's waiting for me to give some confirmation. So I'm going to say something like, okay, continue, or okay, looks good enough, continue on with what you're doing, and ensure no errors, make no mistakes, must be perfect, assure all edge cases and errors are solved. And I'll go ahead and submit that. It's a little disappointing because it took 50 minutes. It is on the auto mode, so maybe if I switched it to like Opus 4.8, it would run a little faster or better. Although I'm trying to sort of balance how many tokens I'm using, so I'm not sure that that would be the optimal solution here. But we'll go ahead and run this. It should probably not take another 50 minutes. I would imagine maybe 20 at most. So we'll go ahead and submit this, and I will cut the video back to when it has completed this. So it made the changes after about 30 minutes. It got a little bit confused at first because it separated the different tests that I had to do, whether it be the if block and the else if, into one phase, and then it separated the measurement stuff into phase 2. And it didn't think that I wanted to do phase 2 yet, but I actually did want it to do phase 2, so I had to clarify that. Now that's been completed, I have not refreshed the page, but I will do that now. And if I scroll down here, it should look pretty much the same. Now we can do the test that I wanted to do, which is getting the RX gate and doing 90 degrees, which will put it 90 degrees and halfway, so now it's 50% in the 1 state, 50% in the 0 states. And then I'll go ahead and measure this. I maybe did not want it to say realities there, although it doesn't look the worst. And wow, I think that looks pretty good. I mean, we can choose now 2 different paths. What if I click one? Okay, looks pretty good. If I click the other, that was not what I was intending to do, but at least that works fine. And that looks pretty good as well. I mean, yeah, we'll go ahead and swap that out. That looks fine as well. Whoops. Still getting used to this a little bit. I guess overall, no path. Then we'll go ahead and apply another RX gate. And this does not seem to be functioning as expected because it does say 100% in the 1 state. But of course that's not true, because if we click on this, you'll see that at least one of the paths, if this is a 0, then the RX gate being applied again, it will collapse here, and then this one will be putting it in a superposition. And even if it was in the 1 state, it will start down here. Rx will put it again in the superposition. So this is clearly false. This is clearly false where it says it's 100% in the one state, because we just saw that one of these tabs had it where it was not 100% in the one state. So we're going to go ahead and copy this and paste this into here, and we'll say something like, I'm noticing a clear error with this. When I run this circuit, it says a 100% chance of it being in the 0, 1, because I guess there are 2 qubits, 0, 1 states. Although, I'll say, which means the measurement isn't collapsing it properly as expected, because if it were to collapse to a 0 or 1, the next Rx should put it back in a superposition, which means there should be some probability in the 0, 0 states. So I went ahead and typed out, of course, if it's saying that there's some probability in the 0, 0 state down one of the realities, then that can't be true, that it's 100% in the 0, 1 state when looking at the overall, because at least some of that percentage has to go to the 0, 0 state. So it's clearly wrong. Fix, make no mistakes, it must be perfect. We'll go ahead and stop the recording and send that, and we'll unpause it once it makes that change. So it's completed, and that one only took about 5 minutes to complete. We're going to go ahead and refresh and see, and it looks like maybe it's correct now. Hopefully it's not just for this case. In fact, we can go ahead and I'm not sure how I can test this. Maybe we can swap it to be a Hadamard instead. Looks like perhaps it's finished now. If I go to the realities, we got a 0, 0 and a 0, 1. Same sort of situation. So maybe there's some circuit that we can choose where it's going to be a little bit different, and I think I can get that working if I, maybe I'll go ahead and put that back there, and then after this, I will make this maybe a 0.25, and that's a little bit surprising unless, okay, maybe it makes more sense. If this is an 85% chance, and it's already a 50% chance, it should be about 42.68%. And then we look at on here, yeah, it's going to be half of that, so it's still 50-50. Maybe we'll go ahead and make it so this one's not perfect, but it's 0.3 instead. And we'll go ahead and adjust this back. Still 50-50. Now this one's 79, and that one's 20, so it's still going to be 50-50. I think what I'm going to have to do is I'm going to have to put a rotate on this one, do a 45 degree, for example, and looks a little bit more complex now. Maybe we'll add something after this as well, and we'll do just some random angle here, maybe another 120. Go ahead and do this. Yeah, that looks as expected as well, where we said put a don't care and a 0. And if we go ahead and set this back to overall 49.15, 0.85, 0.85. That's maybe correct. I mean, I guess the only way we can really see this is we're going to have to go down the other realities here. And that's a term that I believe I've coined as measurement realities. I don't believe it's a common phrase, but I do like the phrase, so I think we're going to integrate it into the website. But if we go ahead and look at this, we should see that, and maybe I should get a notepad. This is the one from before. We're going to go ahead and make some more lines here. So we're saying 1, 0 is, well, first we're saying this has a 50% chance of this being measured as a 0. So 1, 0, has a 78.04% chance of being measured, and 20.26% for 1-1, and 1.35% for 0-0, and 0.35% for 0-1. I don't know if that's accurate, but I would assume that's accurate unless shown otherwise. Go ahead and change this to a 1, and it looks like pretty much the same probabilities, but just in a different order. So now we have a 1-1, 1-0, 0-1, and 0-0. And so I guess the best way would be to maybe add these up and divide by 2. And would that be the correct way of doing this? Let's see. 1-0 has a 49.15%. If we go ahead and add this up, we have 98.3% divided by 2 is 49.15, so that's right. Same for both. Others are 0.85, which would be 1.7 divided by 2, which is 0.85. It looks like maybe it's accurate. I mean, we're going to have to keep adding stuff and see if it's accurate, but this does appear to be functioning as expected. Maybe we can also go ahead and we'll do something like, maybe something a little bit simpler, do this, and see if this, which we requested, can work. So we have the if statement in there based on the C register, the classical register, which holds the value from the measure. Let's see if it did that. That does not appear to be implemented correctly, which, if you recall, that's something that I said, that if we did C1, but C1 doesn't really exist, it should throw an error. So we're going to have to put that in later, but we'll ignore that for now for the purpose of the video. We'll say if C0 equals 1, then we can go ahead and we'll go ahead and apply a Hadamard gate. And so this actually says 75% chance of being measured as a 0, which is pretty interesting. So if I were to measure this and it's in the 0 state, then this would not run, so it would remain in the 0 state, which is a 50% chance. And you'll see that in this reality, 50% chance this is measured in the 0 state, and the other 50%, where it's measured in the 1 state, it then goes into this equal superposition, which gives it another 50-50, so 75 for the 0 and 25 for the 1. I'll see that that remains true if I maybe do something like this. I'm not sure if this will work. Oh, it does appear to be working. So if not C0, so if C0 equals 0, then it will call the Hadamard. We'll maybe see how this works with another measure as well. What if we do a double measure here? So it does appear to be putting it in a equal superposition for the total result. And yeah, I would expect this block sphere to not render correctly, since we're now showing a superposed overall path. Yeah, but maybe if we go down one specific path, that will show. Yeah, that's true. So in this scenario, we measure the Rx, or we measure Q0 after applying the Rx, which would put it in the plus state, or sorry, would put it in the minus I state. Maybe we should do Ry's instead. Do Ry's. Yep, now we will put it in the plus states. It will measure to be a 0, so we'll go back up here. And then we apply another 90 degrees, measure it to be a 0 again, apply another 90 degrees, it finishes in the plus state. What if we go ahead and change this one to a 1? It should now be in the minus states. If we go ahead and set this back, set this to be a 1, then that would mean, and I haven't clicked it yet because I'm trying to figure it out, so I'll try to guess it beforehand. But if we apply Ry 90 degrees, measures to be in the 1 state should be down here, and then our y measured to be a 0 should be back up here, and then our y again, so it should still be in the plus. It's because it still says realities here. So if we measure this to be a 0, yep, it's there. Measure it to be a 1, yep, it's there. Appears to be functioning as expected, besides that little thing which we'll end up fixing, but it's not too big of a deal with the C1, even if we didn't measure a C1. Let's maybe try one more thing where we measure a 0 and a 1. And we'll go ahead and apply the same thing to both of them all of the times. And let's maybe not even measure, we'll not even measure qubit 1 the second time. So we'll say first reality, there should be 4 different outcomes. Second reality, oh, I like that. I was not expecting that, but that is a very great feature that it's decided to add, where it makes us choose this one first. We'll choose, maybe this is in the 1, 0 to begin with. Let's actually go ahead and see how the step-by-step works. So we go up to here, and we measure it to be 0, 1. And this, I believe, is not functioning as expected, is it? Because as we click on this one, this should be after this executes, which clearly cannot be the case because it would have applied the RY. And yeah, that does not appear to be functioning as expected. And it actually appears to be, okay, it does end up changing after this one. What if we set this one back to overall and we step through this? So it steps down there and then back up there. So this block sphere, even in the step-by-step, appears to be just following these gates and ignoring the collapse that happens on the measurement. But when we look at the overall and we click on the run circuit, it does appear to lock. So it does try very hard, and probably we're gonna try to make some changes to the step-by-step after the video. But if we click on maybe one of these realities again, we'll try 1, 0 this time. It does unlock this one, and it does put a don't care on the second qubit. Maybe we'll go ahead and make this a controlled X. And it should now, okay, now it's only locking it to one possibility, which is the 1, 1 state, which I don't believe should happen. Because if this one is 0, 1, then this control will not trigger. So this should still be a 0, 1, but it's saying our only path is 1, 1. Yeah, that does not... Oh, we clicked on 1, 0, and it shows 0, 1 here. If we click on 0, 1, it shows 1, 0 here. So that's maybe a flaw that we found. We can go ahead and click this, and if we look at this again, we'll run this again. It does appear to have confused the order of these qubits. Maybe we'll add one more for good measure. And I'm also noticing a separate bug, which is that it did a 0, 1 for this with square brackets around it, which we never asked for, but it appeared to make that decision on its own, which is another bug we should fix. But if we do this, so we should see 8 different realities. There they are. If we click 0, 0, 1, I would expect if there's an error and it is ordering them in the wrong order, it should say 1, 0, 0. It does appear to be that way. So the total things that we need to fix, and we will do after the video, because it is getting a little bit long, but this is just sort of showing the whole process of development towards pushing features. And now that this one's pretty far developed, this should be pretty much the end. But the things that I will ask it and will continue debugging is that the order on the pop-out tab, oops, actually I'll say the order on the tab below the measures is putting the qubits in the wrong order. If I choose reality 001. It says 100 down there. And I'm not sure how we got these square brackets on the RY. Maybe I did something like this. Oh, see, that's another error, is that it won't let us place a gate before this measure gates. Now it will, but it won't let us if it's sliding, when normally you can do it when it's sliding. And that appears to be something else as well. Now it's just randomly duplicated there, which is very interesting. Oh, it appears to have... Okay, that's even another bug, so now this is sort of going down the drain. But we'll look towards fixing this as well. I guess I'll put... Also, if I have... Oh, now it's done the square brackets. So I'll put also, I had ry012.5, and at some point it changed this to ry with the square brackets 0.5, which is obviously not the correct thing it should be doing, since this is a single qubit gate. It should not be using the square brackets like almost ever. Then we'll put the second error. So now I'm just pretty much saying it makes a second one, which is wrong, and also it makes a second one on top of this ry, which it shouldn't be making a second one, but even if it does, it should not be on top of another gate, so that's wrong. And I'm also putting, when I tried to drag a Hadamard gate between the RYs and the measurement gates, that it wouldn't let me do that, even though I should be able to do that. So I'm going to tell it to fix that as well. And last thing that needs to be fixed is that also it appears that if I'm only measuring C0, it still lets me do C1, etc., and mention them in places like the if statement. I'll put it still lets me, still lets me mention, which I mentioned in my original message should be an error, and we'll actually check if we do an if statement and it has one that's not even on there. Do this. Yeah, it's not throwing an error for that as well. So copy this and we'll say it's also not throwing an error for this, even though C4 clearly can't be used yet because we don't even have a Q4, as once again mentioned in the original message. Then I'll do my classic all caps at the end, fix all of these, make no errors, make no mistakes, must be perfect. So go ahead and send that, but I will wrap up the video here because I believe there's probably enough content, and it's a good demonstration of the process that I take to implement these different features into the Quantum Circuit Simulator. Very time consuming. As you can see, even though it's coding with AI, it takes a lot of effort on my end to ensure quality and to ensure that it's making the correct changes and that it's making accurate changes. If I knew nothing about quantum computing or quantum circuits, I could still ask it to make all of these changes, and it would make pretty good changes up to some standard, and that standard would be a little bit worse than what I'm expecting and that a lot of people would be expecting. So it's still very useful to have this sort of knowledge in both quantum and in how to program and how to prompt correctly so that we can get pretty high quality results.